Okay, so a polynomial function, we know that we put in absolute value, in standard form. This one looks a little wacky. We'll get to it. Just don't think too much about it right now. What is the degree? How do we know what a degree is? Have you guys heard about that? So a degree is the same as your highest term, your highest exponent. Okay? So your highest exponent is a degree. I also want you to write that your zero is your solution. Just write this at the top of your page. Zeros are your solutions. Your degree is your highest exponent. All right, so the rules. The number of solutions of a polynomial is the same, is equal. Is equal to the highest exponent. So just how I say how many answers should we have when we look to see what the highest exponent is, that's what that means. All right, the maximum numbers of terms a polynomial is one less than the highest exponent. For odd functions, with an odd highest exponent, the ends of the functions go in opposite directions. And for even functions, the ends of the functions go in the same direction. Alright, so x to the first power. You guys have been doing this probably since Algebra 1, maybe even Math 8. X to the first power is called a linear function. It is linear. That means that it makes a straight line. Brian, are you writing this down? Okay. We even see the word line that is in it. So my number of zeros is the same as my highest exponent. So how many zeros do I have? Huh? If I asked you how many solutions I would have, it's your highest exponent, so that would be 1. Your max number of turns is 1 less than your zeros. So what is 1 minus 0? Wait, did not mean to write that. 1 less than your 0, so what is 1 minus 1? 0, which makes sense because we have a line. There are no turns in a line. Alright, so let's say I have a positive graph here. Okay, if I have a positive graph, that means that my function is going straight up. That's what that looks like. X to the first power looks just like that. Now granted, your slope will be different. Okay, so if it is minus, it would go down. Any questions there?
Is each graph going to be either plus or negative?
Mm-hmm.
You would never have both positives, right?
Well, I'm just showing you like what your options are. So your option could be a positive graph or a negative graph. All right, x squared. We've seen this before. This is called a quadratic function. Why can't I spell today? Quadratic.
I'm sorry for interrupting.
No, you're fine.
Hi, Siri. Never mind. Okay, I'm not losing my mind. All right.
Okay. So quadratic. That'll be a quadratic function. So my highest number of zeros would be what?
2.
2. So my max number of terms would be 2 minus 1, which is 1. You guys have seen this graph over and over and over. That's all we've done so far. So let's say I have a positive graph. It may look like this. How many solutions do you see? We have 2 real solutions. 1, 2. Because my exponent is 2, I know I have to have 2 answers, which means 2 zeros. Our zeros are just when we cross the x-axis. Alright, if I have a negative graph, and let's say it looks like this, how many solutions do you see? 2. What if, let's say I have a graph that looks like this. It looks like I have just 1, right? But I know I need 2, so that would be what? Such as the dr. Double root. Well, d and r. This would be a double root. You guys can make up whatever examples you want, or you can copy mine. That's fine. Okay? Sometimes it doesn't go actually through the whole line. Alright, x to the 3rd power. What do you think this one is?
3.
3 solutions. But what's it going to be called? It's going to be called cubic. This is a cubic function. Bernardo, how many zeros will I have for a cubic function?
3.
Yep. Ryan, how many max number of terms will I have? 2. It's just 1 less. 3 minus 1 is 2. That helps you when you're drawing the graph. So if I'm drawing a positive graph, our positive graphs are based on our arrows. Notice how I start up high. I need 2 turns. So it's 1 turn, 2 turns. Let's count them out. I have 1, 2, 3 real solutions there. Because that's how many times I'm crossing the line. Do you guys see how this is positive or positive graph because it's going up? My arrow's going up and then it's, okay. So for my negative graph, Ronaldo, stop tickling him. Whatever you're doing. Alright, if I have a negative graph, I start low. Let's say my graph looks like this. Do I have 2 turns?
No.
Yeah, I do. 1, 2. That's why I turn. Right? But how many real solutions do I have? 1. So that means how many imaginaries do I have? 2. I have to have 3 total. So this would mean I have 1 real. And of course you can draw out each your graph if you want. I'm just showing you the harder ones. So I have 1 real, 2 imaginary. Because that one did not cross the x-axis. But we know it's still a cubic graph. All good on quadratic and cubic. Alright. For 4, it is called quartic. Guys are killing me. Quartic. I said Jasmine. What's your name? Carrie. How many zeros do I have here? 4.
No, that's how you know she's a manager.
No, because in 7th period she used to sit there before she went to the other class. Max number of turns, Dennis? 3. Alright, so if I have a positive graph, it could look like this. Let's make sure I can count it. 1, 2, 3 turns, and I have 4 zeros. 1, 2, 3, 4. We're good there. If I had a negative graph, you can draw it with all reals if you want. It doesn't matter. I'll do all real numbers for this one. I have 1, 2, 3, 4. So I know I'm good. If you wanted to do 2 imaginary, you just wouldn't cross over the x-axis. Are you okay? Get a minute, go outside, get it together, get a breather. Yeah, come off the door. Alright, so we know 4 is quartic. A function for 5, pay attention so you don't say this wrong. What does this look like to you? Looks like quintic, right? It is not.
It is 5.
Yes, it is 5. But beside it, I want you guys to write quintic. That's what it is. Quintic.
Then it should be okay.
Well, some mathematician decided it was going to be spelled this way, so that's what we do.
They stupid.
It is quintic.
They stupid.
All right, Sonia, how many zeros do I have?
5.
Beautiful. And Charlie, my max number of turns.
4.
Good. So if I have a positive graph, and for these I normally just count my turns. I start high, I need 4 turns. That's 1, that's 2, that's 3, and that's 4. I turn 4 times. So I have 1, 2, 3, 4, 5 zeros. If I had a negative graph, I'm going to do this a little differently. I start from the bottom. Let's say I have 1, 2, is that enough? 1, 2, 3, 4 turns, yeah. The difference is I'm only crossing the x-axis 3 times, so I have 3 real and how many imaginary?
2.
2 imaginary. Does that part make sense? How sometimes not all your answers will be real answers. That means we're going to have some I's in there. So far, so good? Alright, I think this is where we take a little break, and I'll show you, not break, but, alright. So, flip backwards. Yeah, to the squares. Alright. When you guys get to the squares, I want you guys to write what I'm writing.
How many days is it going to take for us to finish the notes?
2 days.
So,
And then we have a review day.
so we don't do homework yet?
You do.
Okay.
So after this homework, or after these notes, homework A you'll be able to do. And then we'll go over the rest of day 2, and then you can do homework B. Alright, so in one of the boxes, I want you to write even, without the S, even Stevens.
I know Steven.
You guys remember that TV show back in the day? It was back in my day, so you guys are probably not even born.
Where do we write this?
Someone tell Ronaldo where we write it. Early retirement. Alright, even Stevens. And then I want you to give some space, and I want you to write odd, op. What this means is, this is a trick that will save your life. If I have an even exponent, I don't care what it is, it could be any of those. Okay? If we have an even exponent, that means that my end behaviors of my graph will go in the same direction. That's why we say even Stevens. So if it was x to the power of 300, is 300 even? Yes, so that would mean I would have 299 turns. It would be a huge graph, but they would both be going in the same direction at the end. Okay? For odd op, do you notice how it's basically like a mirror? It looks the opposite, right? So that means if I have an odd exponent, like x to the 5th, x to the 9th, x to the 81st, I don't care, x to something odd, your behavior would go in opposite directions. So that op stands for opposite. Yes. So also, when we're looking at this, and we want to know how we start, right? If I have, let's go to a different box. If I have 3x to the 6th power plus 2x to the 4th plus 3. Write that down. I'm not going to expect you guys to graph this. We can tell everything that we need to know. Even Stevens or odd opposite? Even Stevens. So my end behaviors would go in what direction? They will both go in the same direction, right? So let's see here. Let's just do left end behavior and right end behavior. Meaning the left side of the graph and the right side of the graph. Is this 3 positive or negative? Positive. So because it's even Stevens, positive tells me it's going to go up towards positive infinity. Because you guys told me it's even Stevens, my right one would do the same thing. So that in behavior goes where? Positive infinity. We will go over that again in like 3 more slides. But I want you guys to at least be prepared. Does that make sense? Odd opposite, your arrows go opposite directions. Even Stevens, they go in the same direction. Okay? Alright. Back at it. So, classifying by terms. We can describe polynomials by how many terms they have. How do you figure out the terms? They are separated by a positive and a negative. You guys know where we are? It's like a lot of shuffling of papers. So positive signs and negative signs tell us what our terms are, or how many terms. So, for example, if I have one term, it is called a binomial. That means I only have one term.
Wait, is that an M and an I?
M-O-N-O-N-I-A-L. Because the word mono means one. So my example here is 2x cubed. There's nothing else with it, that's all it is. I'm not looking at the degree, aka the exponent. I'm not looking at that coefficient, aka the 2. Number 2, if I have 2 terms, what is that called? We've actually used this word before. That's with a B. Both. A binomial. Both nomial is not it. Creative though. Alright, a binomial means that I have 2 different terms. So I can have 2x cubed plus 3x squared. It's 2, so that's 1 term, 2 terms. Three terms or more, what do you guys think it is? Huh? Yeah, trinomial. For a trinomial, that means I have 3 terms. So that would be, my example is 2x cubed plus 3x squared plus 5x. I'm just making this up. But as you can see, I have 3 terms there, separated by plus signs.
Why do we have to flashbacks?
After this, did you listen to me when we first got here? No. Okay. Well, as you guys are working on your homework, which you'll have plenty of time, I'm going to finish grading your tests.
We're working on your homework?
Yes.
I'll do that.
No, you won't.
Why? I'm not coming Friday.
There's no reason for you not come Friday. You're only not going to come Friday because you think it's a 3-hour release day. And what's the point?
Because I got an SOL testing that day. So,
I'll double check.
I'm be thorough, you can check.
Friday is... Okay, well then you got to get caught up and listen to...
You have one?
No, I mean, I can't even look it up.
I have it already.
There's your name on it.
Duh! It's like, no.
Oh yeah, you have USPA?
Yup.
You want to take it?
No. We'll skip it.
Okay.
I'm just going to take it. Told you.
What are you guys going to do?
Alright, so if you have 4 more terms, that is a polynomial. A polynomial, that means that we just have multiples. Alright, so that would mean, if I'm keeping up with my same example, 2x cubed plus 3x squared, let's do plus 5x minus 10. That's a polynomial, and I have 4 terms. Alright, so it says, let's classify the following polynomials by terms and degree. I'm going to do the degree first. What's the degree here? It is 3. So if we look back, x cubed is cubic, right? That's how we classify it by its degree. And I have 1 term, so what do I write for 1 term? Binomial. Charlie, number 2, what's my highest exponent? What's the degree?
22.
Wait, what'd you say?
Quadratic.
Yeah, quadratic. And I have 3 terms, so that would be what?
Trinomial.
Yes. Ronaldo, what's my highest degree for number 3?
Highest. Is it 3x?
What's this degree?
Oh, 5.
Alright, that's my highest one. So, x to the 5th, how do we say that? No. Kentic. We're doing the degree first, Brian. Kentic. And now, Brian, what's my term? I have 4 terms here. Polynomial. Does that make sense?
So we're literally just naming them. So we're just naming them.
Right now, we're just naming.
Alright, we're not even solved today, right?
We're not solving.
Okay, say less.
We're not solving. Did you understand that? Yes? Alright. Now the practice says, let's describe a couple of polynomials. Look at number 1. 3x to the 5th power minus 2x squared minus x minus 2. Well, first we have to name it. Let's start with the degree. What's my highest degree here? 5. So my degree of 5, we say is what? Kentic. And how many terms do I have? 4. So that will be polynomial. So this is called a Kentic polynomial. Okay, and my degree, what number is my degree? What's our highest exponent? 5. Guys, you're gonna have questions on this stuff. Thank you. Alright, how many zeros do I have? No, careful. There's how many zeros?
1.
My degree is 5, so my number of zeros is
4.
5.
Why is it 5 if you...
Because that's,
6 terms is 4.
yeah, your terms, you subtract 1.
That is a
So my max number of terms is what?
4.
Thank you. That is 4. You guys have to remember your degree is your highest exponent.
So
Okay?
whatever's my degree, that's the same number as the 0.
Yes, remember how we say like our highest exponent is how many answers we should have?
So if it's 500,
Then you have 500 answers.
damn.
Okay? So here's where it gets tricky. We have our left in behavior and we have our right in behavior. I know it's left because it says as x approaches negative infinity, which means if this is our graph, x would be going this way. As x approaches negative infinity, this is where we're gonna, guys, seriously, I'm losing patience. They're actually gone.
The last one is positive.
All right, so look at my 3. Is that a positive or a negative?
Positive.
It is a positive. So my left one will be going up because I have a positive number as my highest degree. Is this going to be even Steven or odd opposite? Odd opposite because of the 5. So my right in behavior is going to go where? Negative infinity. Your in behaviors, you're only writing in infinity or negative infinity. Okay? On number 2, all right, what's the name of this? What's my highest exponent? It's a 4, so that would be, nope. Don't just guess, flip one page and you can see it. X to the 4th is what? Quartic. And I have 3 terms, so that is a trinomial. Alright, Charlie, what's my degree here?
4.
Yep. Carrie, what's my number of zeros?
4.
Brian, what's my number of turns?
3.
3. You have to know that. Your degree and your number of zeros is the same. Your max number of turns will be 1 less. Alright, my in behavior, this is my left arm, this is my right.
Positive.
Stop blurting out.
Nice.
I have a negative that is in front, right? Because that's my highest exponent. So because it's negative, I'm going to start negative. Is this even Stevens or odd opposite? Why is it odd opposite? What's my highest exponent? Is it even or odd? Even. So therefore, it is going to be negative infinity. They're both going to be the same because my exponent of 4 is the highest, and that is an even number. All right. On number 3, how do I name this? Ronaldo, take a seat back.
What am I doing?
Because every time I turn, you guys are giggling. I don't care. Just go back. You're gonna ask me these same questions. And you're gonna wonder why I'm not gonna answer them. All right. On number 3, how do I name this? There are how many zeros here?
3.
There are 3 zeros. So if I have something x cubed, it's going to be what?
Cube.
It's going to be a cubic. I don't have enough information here to know whether it's going to be a polynomial or a trinomial. It doesn't tell me that. So my degree is going to be what? 3. The number of zeros? 3. And my number of turns?
200.
2. Alright, so my left arm is here, my right is there. This is going up, right? So my left arm is going up to what? Positive infinity. And my right arm is going down to negative infinity. We know it's cubic, which is odd, so these have to be opposite. But we had our graph there to show us anyway. Alright, my next slide you guys do not have, so I want you to go back to your boxes on the back of your assignment sheet. And I just want you to write this in. Okay? This is, huh? Do you have it? I have it.
I have it.
Okay. I'll double check my other packets, 'cause I think I messed up somewhere. Alright, well then, go to this page then. Oh, I'm missing a page in some of these. Dang it. So everyone in here has it, right? All right, great. All right, so graphing polynomial functions. We should understand how to do this by now. This a here is my slope. It can tell me two things. If it is bigger than 1, it tells me to do what? Nope, that's
Rise
small.
over right.
Renata, stop. It tells me to stretch if it is bigger than 1. If it is smaller, I'm going to compress. What about if it's a negative? What does a negative tell us to do? It would tell me to reflect.
Is that the same thing as well?
Yes. Alright, this H here can tell me two things. Which way to go? If it's negative, which way do I go? No,
Right.
I go right. If it's positive, I go left. My K tells me directions vertically. If it's negative, I go down. And if it's positive, I go up. Same thing for the other one. Alright, so continuous functions do not have breaks. Continuous functions do not have breaks. What that means is I can get, if I have a graph, that means if I get from one arrow to the other, my pencil does not get to pick up. It is continuous the whole time. One-to-one functions pass the horizontal line test. That means if I have a graph that looks like this, and we wanted to do a horizontal line test, if I drew horizontal lines, would this pass the test? No, because it's touching in more than one place. Does that make sense? Okay, so that's the end of day 1. Your homework is double A. You can actually do it now. 1 through 5 is a chart. 6 through 11 is matching, which I want you to do without a calculator. And then you have to name your polynomials, and then you're doing your transformations. This homework is not hard. You guys should have plenty of time to be able to finish it.
So this,
Does it say homework AA?